Aloha, Rich Halverson here. This is ITS128, and in this video, we're going to cover Chapter 6, continuing with um, branching. So let me share my screen, see how I do this now. Share this one, and I'm going to move this out of the way. All right, so let's move this out of the way. Okay, so here we are, and so let's do branching too. So this you're gonna use what you learn in this chapter a little bit less than you do in the previous chapters. So there's some additional operators that you can use to test if branches should take place or not. And so one of them is this in not in membership operator. And you can use that with lists. Like let's say you have a list here, and that's got 3 items in it, and you want to check if 15 if 15 is in the list, and if it is, and that would evaluate to true, and this thing evaluates to false because 44 is not in prices. So this is an actual Python statement that you can type in, and this is an actual expression. And so 15 is a value, in is an operator, and prices is a list. See? So here's an example. You've got a list that's got 3 items in it, and then you input a name, and then you want to see if that name is in the list. So you just say if name in list. If this is true, then it's going to say it found the name in the roster. Otherwise, if it's not true, it's going to say it could not find the name. So and it works for strings, looking for substrings. So if you have a string and you want to see if there's a substring in the string, you can use the in operator. For a dictionary, you can see if there is a key value in the dictionary. You can't use in to see if there's a particular value in the dictionary, but you can use it if you're looking for a particular key in the dictionary. So here, we have an A and a B and a C. So is B in the dictionary? Yes, it is, because here it is. Is 3 in the dictionary? No, it's not, because it only looks at the key values. It doesn't look at it only looks at the keys. It only looks at the value of the keys. It does not look at the value of the values, at the value. So anyway, I think you know what I mean. All right, so there's also see, this is in, and there's also is. Okay, and that tests if two objects are the same object. So basically, it's testing to see if the address of the object in the physical RAM memory is the same for the two. Okay, and to really understand this and use it, you have to sort of understand that constants. These constants sometimes a test like this may be true. But a test like this may be false, even though x is equal to 3 and y is equal to 1,000. Say, okay, so let's look at that again. Let's say you have y is equal to 1,000 and x is equal to 3. Okay, and you decided to use this is operator instead of a double equal sign. Well, it turns out that this will evaluate to true, but this will evaluate to false. Why? Because it turns out that the way the Python runtime machine works, if there are small values like this, it'll actually create a constant. It'll create a memory location with that constant value in it, and it'll set, like if there's a bunch of variables that are equal to that value, it'll set all those values equal to the same object. Whereas if we are setting a variable equal to a value that's not a small value, but a big value, a big value which likely would not be used again in the same program, that there it actually creates, it would actually create a new object for each time you set something equal to 1000. It would not use the same object. So that's kind of peculiar. It has to do with understanding a lot more about the underlying runtime machine, Python runtime machine, which I think is necessary, whatever. You can always test directly using the double equal by looking at the ID of a variable. This is the object address, the address of the variable in the memory, and you can see if they're equal. And if their IDs are equal, then that means that they're both the same, actually the same object. Let's see, we can see some examples of this here. Well, I'll tell you what, let's just do a challenge activity here. Okay, so we have some numbers here. We have a list of numbers, and we read in a number X, and then we're going to test this. We read in this number X, and we're going to test to see, let's start this up. If X is in numbers, and if it is, it outputs an in, it outputs in, otherwise it outputs not in. Okay, so we read in 5. Is 5 in numbers? This is going to evaluate to true, so that means this will print. So it'll print in. Okay. This one will 5 is in numbers, so this would evaluate to false because it's not true that X is not in numbers. It's not true that X is not in numbers. It is in fact true that X is in numbers. So that's why the output would be in, because X is in anyway. So anyway, you can do that. I'm going to do the last one here because this one's kind of interesting. Okay, so we have a variable called A, and this is set equal to bird. We have B, which is set equal to fish. These are constant values. And then we create a list called which contains A and B. Okay, so this is a list. This is a mutable. This is mutable. These are immutable, and that sort of matters here because when we do something like this, we set D equal to C. We are saying that D is the same object as C. Here we're saying that A is a constant. It's a value called bird. It's a constant value called bird. Here B is a constant value called fish. C is a list. The list contains both A and B. And then we're saying D is the same list as C. So now when we want to change the first element of D to panda, we're actually changing this to panda. So let's see what this is. Is B is D1. That is true because D is the same as C, and B so since D is the same as C, then this is D0. Okay, this is C0 and this is C1. It's also D0 and D1. Okay, so B is D1. Yes, it's true. So it does print F. B is D1, yes. Is C equal to D? C is D. Yes, it is true. So it prints a G. It's true because C is the same object as D. D is the same object as C. And then is A equal to D0? A is bird. D0 is now equal to panda. So it will not print H because A is not D0 anymore. D0 is something different than A. A is bird. D0 is panda because of this. So it's not going to print the H. So let's see if this is right. Ah, good. It's right. All right. So let's try this one. Using to detect specific values, write an expression using membership operators that prints special number if special num is one of the special numbers stored in this special list. Okay, so we're just going to say if special num uh, is in special list, then print special number, otherwise don't print special number. That's right. Yep. All right, so I'm gonna run this, I guess. Okay, I got it. Okay, very good. All right, order of evaluation. This is pretty important to understand. Okay, this is one of the things about being a computer scientist. Computer scientists have to know this very, very well because we mess around with expressions a lot. We mess around with expressions a lot because when we get a formula from a math guy, from one of the math people, we get a formula that our program is supposed to implement. We have to take that formula and convert it into one line or a couple of lines or whatever to be able to calculate the equation that somebody else gives us. And so we have to manipulate how it looks. And so it's important that we understand when we have a whole big long expression, it's important to understand which parts of it are evaluated before other parts are evaluated. So there are these things called precedence rules, okay? And if you see an expression like this, the first thing you're going to do is you're going to go to the innermost parentheses, okay? Inside those, or inside any parentheses, you have these operators. These are the arithmetic operators. These manipulate numbers. And then you have these operators, and these operators compare. They compare things, and they evaluate to either true or false. It's either true or false that the thing on the left is less than the thing on the right, and so on. And then we have a not operator, which operates only on Boolean values, which operates only on things that are true or false. So not true is false and not false is true. And then we have these and operators, and they're kind of like, the and operator is kind of like multiplication, and the or operator is kind of like addition, except for these and operators and or operators, they operate on variables or values that are Boolean variables or Boolean variables or values, which means they're either true or false. They're not 1, 2, 3, 4, 5 or whatever. They're either true or false. So not is like it's like a minus sign in front of a variable or a number, and is like this. If like an expression like this, first you evaluate the order of precedence is first you have to evaluate what's inside this parentheses, and then you evaluate what's inside this parentheses, and then you evaluate what's in what the outer parentheses. But anyway, you do the inside ones first. But inside the parentheses, there's an order, and these are double equal signs, and those are right here. So first you're going to do this inside the parentheses, and so you're going to say is y equal to 10? It's either true or false. And then you're going to say, is z not equal to 10? It's either true or false. Okay. And then then you have something here that's either true or false, anded with something here that's true or false. And for the whole thing to be true, they both have to be true, right? So that's how and works. So anyway, you just have to know that in an expression, you have to know what's evaluated before what else is about. You have to know what's evaluated first and what's evaluated second. And if according to the operator precedence, it's not going to evaluate correctly how you want it to, then you can just throw parentheses in there to make sure that those inside the parentheses get evaluated before some other, operator. All right, so which illustrates the actual order of evaluation via parentheses. So here we're looking at not green is equal to red. Now, in here, it looks like equal has not equal and not equal has precedence over not. So in this thing, this gets evaluated before the not is applied. So this is the expression, I think. Yes, it is. Okay, because what's inside the parentheses is evaluated before the not is applied. And that's what this is, because this double equal sign is going to be evaluated before the not. Okay, so that's how that works. Here we have bats is less than birds, or birds is less than insects. Okay, there the less than or equal sign has precedence over the or. So the first thing that's going to happen is these get applied first. So that means that it's so these get applied first, then the or gets applied. So this is the correct answer. See how that works? See how the operator precedence works? If you mean this, that's what you mean, you can just put this. However, up here, if this is what you mean, no, if for example, if this is what you mean, then you don't just put this. This is not going to be not green is equal to, it's true that not green is not green is equal to red. Well, it's not always true, but anyway. So if you want first this to be evaluated, then you want to test if this is equal to red, then you have to put this, because you want the not green to be evaluated before the equal sign. Because if you just put this, it's going to end up being that. Anyway, so that's operator precedence. So if you're in doubt, just put parentheses in there. Okay, so this is the third section here is code blocks and indentation. In Python, indentation is telling the compiler something. It's saying that it's a code block. All this code that's indented, it's a block. Okay. Here, let's find something that's better. What are we supposed to do? We're supposed to correct the indentation. So this statement is executed, this statement's executed, so is this, so is this. When this statement executes, this test is evaluated. If it's true, then you do the indented block. If this is not true, then you skip the indented block and you just go to the next statement that's in line with the if statement. Here, if this is true, only then do you evaluate that. Only then do you execute this statement. If this is not true, then you skip the indentation and go back out here and you execute this one next. Okay, so that's how indentation, code blocks and indentation. Fix the errors in the code below so that you can run the program. Okay, so this is messed up because you've got a block here and it doesn't even do anything. If this is false, then this what happens when I run this? Do I just get errors? Oh yeah, I get errors. Unexpected indent. Okay, so on line 4, oh, look, this is indented for some dumb reason. So basically you gotta just fix all the indents. If this is true, then that's true. You probably want it to be there. else you probably want this to be there. You probably want this to be there. And see if this works. Yeah. All right, whatever. Okay, so except for there are some special cases. Let's say you want to set some variable equal to a really long string and it's way more than 80 characters, 120 or 120 characters or whatever. What if it's really long? Well, you can do it this way. You put parentheses around it, apparently, and then you can just do this quote, and then you go on to the next line and you quote the next line like that, and you go on to the next line and you put quotes around it until you're done. You close the parentheses, and these all have to be in the same. Apparently, these all have to be in the same indentation level. And you can do it for something like this. If you have if you're calling a function or a method, and these are the arguments for this method, and like they got long names, and you got to use more than one line, you can do it this way. Notice the indent here is the same. And for dictionaries and lists, you can do it this way. See here you're declaring a list. It's got 6 elements in it, and you're using more than one line. Here you're declaring a dictionary. It's got 2 elements in it, and you can do it this way. It's very convenient. All right, so here you just got to fix the indentation. These are real easy. You should be able to do these. All right, you just take this here. You should be able to do this. This should just be second nature. Okay, let's bring all this in. Let's bring this in. Oops. And let's indent this, indent this, indent this, indent this. If New York is in temperatures, so you're going to read something here. When this thing executes, when it gets to here, it's going to ask the user for something, and then it's going to put it in, and that's what that's what the temperature of New York is going to be. And then it tests to see if there is an element in this dictionary. This is a dictionary. Is there an element in this dictionary with the key value New York? Yes, it is. Yes, there is. There it is. And if the temperatures of that value is greater than 90, then it's going to say the city's melting. Otherwise, it's going to say what the temperature is. Now, if New York is not in here, it is though, but if it's not, it'll just say the temperature in New York is unknown. Okay, so. All right, so. And here you're just supposed to fix the indentation. Yeah, it's pretty easy. You should be able to do that. It's only in Python. Most every other language, the indentation doesn't mean anything. All right, let's go on to conditional expressions. And so this is kind of unique in Python. You have an expression like this, where you have an expression, and that expression this expression is evaluated. Wait a second, how does this work? Okay. Expression when true. Oh, this is the expression when it's when the condition equals true. Okay, so you have a variable. The condition expression is over here. Okay, so it's you have a variable, and that's this variable. You're gonna geez, it doesn't let me move it. Well, you have a variable called marvar, and it's going to evaluate this condition, and if this condition is true, then it's going to set myvar equal to this. Otherwise, if this condition is false, it's going to set myvar equal to this. So it's the same as this. If condition is true, it sets myvar equal to this. Otherwise, it's going to set myvar equal to this. So they're the same thing. It's kind of nice, I guess, shorten it up a little bit. So here we have, it's my number is equal to 6, your number is equal to 1. If my number is greater than or equal to 2, otherwise it's equal to 3. So print your number. Okay, so if my number is 6, then this is true. This is true. So that means that your number is going to equal 1. And so when we print your number, we're just going to print 1. Okay, let's do the last one. Here we're going to say we have my number is equal to 10. If my number plus 4, your number is going to be equal to 14 if this is true. Otherwise, your number is going to equal to my number minus 4, which is 6. Okay, so it looks like because this is false, then this is going to be equal to this. And this is equal to 10 minus 4 is 6. So this is going to equal 6. And so we're going to print 6. Okay. Create a conditional expression that evaluates to string negative if the user value is less than 0 and non-negative otherwise. Okay, so we read in something and we're going to say it's going to print. This is going to be is negative or is non-negative. Yeah, negative or not. Okay, so conditional expression is equal to negative if user val is less than 0. Otherwise, else non-negative. Okay, so conditional string is going to equal to this if this is true. Otherwise, conditional string is going to equal to that. Okay, let's see if this works. All right, very good. Okay, I guess we can do one more here. Reads the number of users, reads an update direction. And so if it's going to be, if the inputs are 8 and then 3, write a statement that increments number of users if update direction is 3, otherwise it decrements users. Okay, so update direction is 3. Okay, so users equals increments num users. Num users equals num users plus 1 if update direction equals 3. Otherwise, it decrements num users. Num users minus 1. So if update direction is equal to 3, then num users equals num users plus 1. Otherwise, if update direction, if this is false, it's not equal to 3, then num users equals num users minus 1. Increments if one, otherwise decrements. Okay, let's see if this works. All right, very good. Okay, you can do this one. Check this out. All right, this one, this is a this is, you have the answer to this one. Oh, I wrote the answer here too. So I already did this one. So you have the answer to this one right here. So work on it, and you see the solution here. Anyway, you can do better than the solution. I just basically showed you. I'm going to do this one here. Okay. I'll do this one in class today. It looks like we're going to end early today. That's kind of nice. So what we're supposed to do in this one is we're supposed to read in 3 letters or 3 characters, and we're supposed to figure out. We're supposed to output them in alphabetical order. Okay. And the hint is ordering 3 characters takes 6 permutations. Okay. So what that means, 6 permutations. Okay. Did I write it? Shoots. I gotta I want to derive this. So can I make it go back to the original? Let's try storybooks.com. I'm gonna go sign in. I'm gonna go to we are in chapter 6. This one. Okay. All right. I don't have the answer, the solution here. Okay. So it says 6 permutations. Can I make this a little bigger? Okay. By 6 permutations, they mean, I want to put some comments here. Oh, it's not comment. It's okay. So by 6 permutations. Okay, so they're saying the possible when you read in, okay, so we're going to read in character 1, character 2, and character 3. Now the only possibilities are character 1 is comes first, then character 2, and then character 3. There's that permutation where 1 like A, B, C, like if this is A, B, C, and then A is less than B is less than C. That's one permutation. Another permutation is C1 is less than C3 is less than C2. So that's a second permutation. Another permutation is if C2 is the smallest. Let's say C2 is the smallest, and then followed by C1, and then followed by C3. Okay, that's another permutation. Or we can have C2 being the smallest, followed by C3, followed by C1. Okay, that's a fourth permutation. Finally, we can have C3 as the smallest one, and after that we have C1 as the next smallest one, and then we have C2 as this next smallest one after that, was the largest one. And then the last permutation is C3 is smaller than C2, which is smaller than C1. Okay, these are all 6 permutations. Okay, this is taking our hint here. Well, so we can turn these into if statements. Let's do that. I'm going to, first of all, I'm going to read C1, C2, and C3. Okay, so I'm going to do, let's see, let me just do this. And the comment. And I'm going to say C1 equals input, C2 equals input, and C3 equals input. Okay, so now I got the 3 things in there. And then I'm going to do if that is true, then print C1, comma C2, comma C3. Okay, just like that. Right? That's what it is, right? So we can do this for all of them. Let's do if space, if space, if space, if space, if space. And then I do colon, I do colon, I do colon, and I do colon, and I do colon, and then I do print. Right here, I do print C1, comma C3, comma C2. And then I can do print. In this case, it'd be C2, followed by C1, followed by C3. See, I'm doing this one. C2, C1, C3. And this one is going to be print C2, C3, C1. And this one would be print C3, C1, C2. And this last one would be, I'm going to get rid of this comment thing because I don't need that anymore. Print C3, C2, C1. Okay. I think this will work. Let's see if this will work. Oh my, that worked. Okay, so anyways, so that's one way. I'm going to show you another way. There's lots of different ways you can do this. I'm going to start out by saying if C1 is less than C1 and C1 is less than C3, then if C2 is less than C3, oh no. If C1 is less than C2 and C1 is less than C3, then start out by printing C1, comma, and equals, because we don't want to print the return, right? Because we have to print the next two, okay? And then if C2 is less than C3, Then we're going to print C2 comma C3, just like that. And then let's do, so that takes care of all the C1s we have. So we can get rid of this. Now let's try the C2s. If C2 is less than C3 and C2 is, no, and if C2 is less than C1 and C2 is less than C3, then print C2 comma and equals space like that. Then if C1 is less than C3, then print C1 comma C3. I'm not done with these yet. I can see. I have to do another case. So let's just finish up what I was doing here. If C1 is less than C1, if C3 is less than C1 and C3 is less than C2, then print C3 comma and equals. Then if C1 is less than C2, then print C1 comma C2. Okay. I gotta do the else kid. This is only gonna print C1, C2, C3, or it's gonna print C2, C1, C3, or it's gonna print C3, C1, C2. I gotta do the else case. If C2 is less than C3, then print that. Otherwise, print C3 comma C2. See. So if this is the case, then you want to print C2, then C3. Otherwise, if this is false, then you want to print C3, then C2. For this one, if you print out C2, because it's the smallest, and then if C1 is smaller than C3, you print C1 then C3. Otherwise, you print C3 comma C1. And this one here, if C3 is less than C1 and C3 is less than C2, then we print out C3. And then if C1 is less than C2, we're going to print out C1 then C2. Otherwise, we print C2 comma C1. Okay, so that's another way of doing it. Let's see what this does. Ah, yes, I got that one too. Okay, well, anyway, I think that's I covered this chapter. We're going to end a little early today. And so I'm all caught up, and it's 2:34, and I'll see you next time. Thanks for watching.